Our next presentation is from Lauren Stalbow from the Icahn School of Medicine, Mount Sinai, New York. Her talk is the interplay between polygenic and rare HNF1A variant risk in patients with type 2 diabetes. Lauren, please.
Thanks so much for the invitation to present. So today I'm going to be speaking to you about a project that looks at the impact of type 2 diabetes, polygenic susceptibility, and rare functionally damaging HNF1A mutations on the risk for diabetes. And so we use the 5 populations that are shown here on the left-hand side of the screen, 2 from the UK Biobank and 3 from the Mount Sinai BioMe Biobank. We then calculated polygenic risk scores for each of the cohorts, and at the same time identified carriers of rare functionally damaging HNF1A mutations. We then looked to see the effect of carrying one of these variants at the low and high ends of the type 2 diabetes polygenic spectrum. And so to briefly go over the methods, we identified carriers of rare non-synonymous HNF1A mutations that have been demonstrated to impair function less than 60% in either a transactivation or nuclear localization assay. We ended up with 36 variants that met our criteria. And for the analysis that I'm going to show you today, we focused on mutations that were found within the functional domains of the protein. We then generated a type 2 diabetes polygenic risk score using PRSCS for each of the groups. And notably, these were transancestral PRSs for all of the cohorts, except for the UK Biobank European group because of overlap with the initial GWAS. So moving to the results, to start, we looked at the individual associations of the polygenic risk score and of carrying a rare variant, which I've called RNV for short, to type 2 diabetes. And so on the screen, what you're seeing are the odds ratios of diabetes for carriers of one of these variants, as well as for the polygenic risk score per standard deviation by each of the 5 groups of interest. And so the first thing to take note of was that the PRS was associated with type 2 diabetes in all of the cohorts. The second thing we saw was that carrying one of these rare non-synonymous variants was associated with type 2 diabetes in both of the European ancestry groups. We also saw directionally consistent results in the non-European ancestry populations. And so we then took everything a step further. We wanted to look at the impact of carrying one of these variants and having a high PRS. And so to orient you to what you're seeing, we divided the groups into quintiles by their polygenic risk score distribution, with 5 being the top 20th percentile and 1 being the lowest. And we then stratified by HNF1A carrier status as shown by the colors on the slide. We used the middle quintile non-carrier group as the reference. And so what we found was that in people of European and Hispanic Latino ancestries, carriers in the top quintile had a markedly increased risk for type 2 diabetes. And just as an example, highlighted in pink here, Hispanic Latino carriers in the top quintile had a more than 8-fold increased odds for diabetes as compared to the roughly 3-fold increased odd for the top quintile non-carriers. And so our takeaways are that functional studies were helpful in identifying variants that predispose to diabetes, particularly when the carrier had a high polygenic susceptibility for the disease. And this study could help identify individuals who could benefit from more precise disease prevention and management. And so thank you, and I will gladly take any questions.
All right, good. Let me encourage the audience to pose questions during the talk. These are short presentations, so we need to get the questions up front. We have a couple of questions here. One says, do these adult type 1 disease, I'm sorry, that related to the last presentation. So the one for this one, have you confirmed that these rare HNF1A variants are non-MODY causing?
Yeah, it's a good question. So so for this analysis, we included all variants that met the criteria of impacting the transactivation domain or nuclear localization below 60%. So that would have included MODY causing mutations. But what we've seen with these population-based biobanks are that oftentimes carriers of these mutations don't necessarily manifest MODY as traditional MODY. And so their age of onset might be later than maybe what you would expect and things like that.
So another question relates to, can a low PRS be protective?
So what you can see, and if you go on to look at the poster, you'll see that carriers of these mutations at the low end of the polygenic spectrum typically had similar rates of, or similar odds of diabetes as the non-carriers. So I don't know if it would be considered protective, but maybe attenuated, something like that.
All right, good. Well, thank you very much. And let's go ahead and move forward.